Question number 6 from section 4.5, exponential logarithmic equations. Solve the exponential equation. Express irrational solutions as decimals correct to the nearest thousands. Now this equation is an exponential equation, although it has two bases. 4 is the base on the left side raised to the x minus 4 power, and 3 is the base on the other side raised to the 2x power. So it's not an easy transition to go from this form to this form because we actually have two bases. So a way around that is actually by taking the logarithm of both sides, and I'll show you what that means. And when you take the logarithm of both sides, these exponents you can bring out in front. That's one of the properties of logarithms. So if I take the log of the left side and the log of the right side, let me write it like this. The log of 4 to the x minus 4 has to equal the log of 3 to the 2x power. Now using the properties of exponents, this power I'm going to bring out in front of the logarithm. This power I'm going to bring out in front of the logarithm. So we can rewrite this equation as x minus 4 times log of 4 equals 2x times the log of 3. So again, we took the log of both sides and using the properties of exponents, properties of logarithms, so anytime you have a log of something raised to the power, you can bring that power out in front. Now we're going to distribute the logarithm 4 on both, on the left side to get x times the log of 4 minus 4 times the log of 4 equals 2x times the log of 3. Now what we want to do is get the x by itself. We can, notice we have an x over here on the right side and an x over here on the left side. We can subtract x log of 4 on both sides of the equation. And what that does is it gives us on the left side negative 4 log of 4 equals 2x log 3 minus x log 4. We want to get the x by itself. Notice we have an x here and we have an x here. We are going to factor out the x. The left side we're going to keep as negative 4 log 4 equals, and we're going to factor out the x. When you factor out the x, you get 2 log 3 minus log 4. Now the goal in solving the equation is to get the variable x by itself. We are going to divide both sides by this big common factor 2 log 3 minus log 4. Divide that on both sides. And when you do that, the 2 log 3 minus log 4 is going to divide out. So you do end up with x all by itself. So the solution to the equation is x equals all of this. Negative 4 log 4 divided by 2 log 3 minus log 4. That's a whole lot of logs there. But we can simplify this by using a calculator and rounding our final answer to the nearest thousandths. Now be careful when you use a calculator to evaluate this. You may want to write out the decimals and really simplify before you get your final answer. On my calculator, I can put parentheses around the whole numerator and the whole denominator so that I am able to get the answer in one step. So I'm going to use parentheses, negative 4 times the log of 4, close the parentheses twice, see with the parentheses around the 4, And then I'm going to divide by more parentheses, 2 log 3, close the parentheses, minus log 4, close the parentheses, twice. And I get negative 6.83804. If we round this to the nearest thousandths, that is negative 6.838. Negative 6.838. And we can check our answer. The hardest part of this could be putting it into your calculator. There is quite a few steps in solving this. Both sides have a base, both sides have an exponent, so it's not an easy conversion to make it look like a logarithmic equation. So what you do is you take the log of both sides, and then using that power of logarithms, any exponents, bring them out in front. Then we distributed, and we got the x's on one side of the equation, and we factored out the common x, divided out to get our x by itself. Round your final answer to the nearest thousandths. All right, let's take a look at question number 7. Solve the exponential equation, express irrational solutions as decimals correct to the nearest thousandth. Now we have an equation, we have 0.02 times 1.18x to the x power equals 2. Now it's not quite in the form of a logarithmic equation. If we had a base, an exponent, and equal to an argument, then we can convert it to this form. So what I'm going to do first is to make it so the left side only has a base raised to the exponent t. I need to get rid of this 0.02. I'm going to divide both sides by 0.02. When you simplify this, you get 1.18 to the x power equals 2 divided by 0.02. Which is 100. Now we have an equation that has one base, one exponent, and one argument. Convert this to logarithmic form. So we have, I'm going to write this as log base 1.18 of 100 is equal to x. Now the way we're able to convert it is that it's written only as one base, one exponent equals the argument, and then convert it to logarithmic form. Now we can use a calculator to evaluate log base 1.18 of 100. Using the change of base formula, we want to evaluate log of 100 divided by log of 1.18. So log of 100 divided by log of 1.18. And we want to round this answer to the nearest thousandths. And that will give us 27.823. Let's check our answer. 27.823.